you will see for instance, yes, here you will see the rain sensor. Just add this rain sensor. Okay. Then nothing more than this rain sensor you need. Just you need Arduino board. So just select Arduino board and a toggle switch you need, or you can say logic select you need. Just logic select. Just select this logic switch. I think Arduino we have not imported. Arduino. So just drag and drop the Arduino Uno board there. Okay. So you place your rain sensor there. And connect out pin of this rain sensor with the 13 pin of Arduino board. Give ground to this ground pin. Give power to this VCC pin. Right. And at this test pin, just put your logic step there. All right. Now for visualizing the output, just connect your virtual terminal. Connect the receiving pin of this virtual terminal with the transmission pin of Arduino board. So it's a kind of UART communication. Okay, UART serial communication. Now just write the program in Arduino IDE. Okay. So just start the serial communication. Pin mode. We have, I think, connected the output of this pin at 13th channel. Okay. So the output of this REN sensor can be opted at this 13 pin. So this 13 pin is configured as input pin. Right. In the loop, we are reading from this 13 pin using digital read function 13. When variable have value 1, then just print println because its output of this range sensor is always digital, so we can put else here. Okay. Just compile this code. Replace this file. I think I have already saved this program in the previous session. PRINTLM. Okay, just locate its hex file generated in the background. Just copy the path of this hex file and put it into this Arduino program. Okay, click on OK. So if you now just click on this simulation, the system will give an error. Okay, AVI program is not defined properly because in the previous session I have already told you that these are the external modules that are not available inbuilt in the Proteus software. So when we are going to integrate this external module with the Proteus, we also need to embed their corresponding program in these modules. So just click on this, double click on this Ren sensor, click on program, and navigate to the folder where we have extracted the zip file for Proteus import. Just select this hex file there. Now start the simulation. Okay. So currently there is no rain. Using this test pin, I am going to change this to logic 1. There's the logic 1 reached to this test pin. The output of this get 1, and now the Arduino board is saying it's raining. Again, let's say it's 0. No rain. Okay, because it's this part is basically used for emulation purpose. That's why we are using this test pin here. So if you have physical component of this HL83 board, which is typical a Ren sensor, then you will not be able to find this test pin there, because on the physical board this circuit will work as a normal operation. Just if you drop just a water drop on this this sensor, you will find the same message there. And if this plate is get dry, then you will get the no rain message. The same function will work with the physical hardware. There will not be any test pin was there, right? Okay. If you have any doubt regarding in this experiment, you can ask me. Otherwise, I will proceed to the next experiment, that is heartbeat sensor integration. If anybody have any doubt regarding this integration or interfacing this sensor with the Arduino model, you can ask me. Okay. So next practical is connecting a heartbeat sensor with this Arduino board and get the reading from that sensor. So just delete these components, all these components. This is screen. We have a heartbeat sensor. It's a kind of analog sensor, right? For the analog pin, this Arduino board was not working. There was some problem in the library, so I'm using another board, Arduino Uno. So just connect this VCC pin to corresponding power signal. That's 5. Put ground there. And connect V out of this sensor, heartbeat sensor, to the pin of this A0. At the serial port or serial monitor, we are going to monitor the heartbeat. So just write the program for heartbeat sensor. For interfacing the heartbeat sensor, you need to download a library in the Arduino IDE. So just click on include library and select the manage library option. Okay. By default, this heartbeat sensor is not installed in this Arduino IDE. So you need to install the Arduino IDE library. Sorry, this heartbeat sensor library in this Arduino IDE. Okay, just type pulse sensor. You will see an option pulse sensor playground. So this is the library that is generally used to interact with this pulse sensor or heartbeat sensor. So you just need to select the particular version and just click on this install function. In particular, this case is I have already installed this pulse sensor playground library in this Arduino IDE. So and at this particular time, I do not need to install it again. So I'm just going to skip this step. Okay. At your system, for the first time, you need to install it. So now it's time to write the code. We can do one thing. We can connect a LED at 13 pin. So as and when this heartbeat pumps, the heartbeats get visualized. The same visualization could be obtained at this blinking of this LED. So I'm just going to implement this. So that's why I have a variable constant integer LED 14 constant pulse wire that is been connected to A0. Okay, in this diagram we have connected the output of this pulse wire to A0. Okay. This threshold variable I am using for generating the peaks, or you can say the generating the heartbeats of a particular human being. It can be reconfigurable. So you need to just get a reading and just fine tune this threshold variable to get an exact heartbeat. You just need now to make an object of this sensor playground class voids the start sensor log input wire. On the pulse wire, we are getting the input in the pulse sensor and initializing the blink LED that on the pulse it will blink the LED that is defined with pin number 13. Okay. Similarly, we are setting the threshold value that we have defined in the constant with the help of this threshold variable, constant threshold value. So if sensor is started, we are printing a message sensor initialized, okay, or in the loop just obtain beat, that is beat per second. Sensor. This sensor dot start of beat. The pulse sensor since the start of beats, it will print BPM, that is beats per minute. Whatever it has received from its analog input and a delay of 20 or whatever 30, whatever milliseconds you want to set. Okay, just save the name you desire. Okay, compile it. Sensor. Sensor is not defined. Sorry. Sensor was not declared. Okay, I have to put this link. Just select the path of the text file, paste it in this. Similarly, the program file of this heartbeat sensor. Just select mask. So just load their corresponding program into that and start the simulation. Wait. I have not connected this test pin with the input. How will I simulate the program? So for this, just have a potentiometer. Just put a potentiometer there. Connect this potentiometer with this test pin. Give supply or ground correspondingly. Okay. So now start the simulation. Sensor initialized, but no reading is there. Change the reading. Just a minute. Why it is not connecting? Just let me check the voltage at the probe. Yes. Now you could see the heartbeats. Okay. So in that manner, you can simulate the heartbeat sensor, right? Okay. So is there any question in that heartbeat sensor simulation? If you have any doubt, or should I proceed to the next experiment? That is, we will connect a real-time clock with our Arduino and get the latest date and time with that. So in my first lecture, when I have demonstrated my research, one of my research projects, there we have used the real-time clock for synchronizing all the sensor nodes with each other. So I will make such kind of scenario with that in this experiment. Okay, I will try to manage to do such kind of simulation. Just search for RTC. It's real-time clock. You will see a real-time clock there. Just search for real-time clock. RTC. Where it is. DS10 DS10371037. There is no DS1037. I think we need to type DS1037. 37 is not there. Real-time clock RTC. DS1307. Okay. So just select this DS1307. Then add Arduino Uno is already there. Then have a resistance. Okay, just use generic resistance. Automatically, it will have a value of 10K. Then visualize the date and time. Just select LCD. 04 of 20 cross 4 alphanumeric LCD. It means you have a 4 rows and 20 columns, right? Okay. So just start the connection. Place the Arduino board there. Place your real-time clock module there. Okay. We need a crystal oscillator here. By using this crystal oscillator, we could able to apply the frequency or generate the frequency and give this frequency to this real-time clock so that it can generate pulses of seconds. Okay. Here you need crystal oscillator. Just select crystal oscillator, place in between them, and give this frequency of this crystal oscillator to 32.768 kilohertz. Place two resistors there. Supply power to them. Connect their corresponding SCL. SCL is connected to pin number 85, and SDA is connected to pin number 5. Okay. This, that one, and this two. That one. And now we need virtual terminal. Transmission of this virtual terminal to this. Okay, we do not need the virtual terminal. We are going to interface with this LCD. So rather than having a virtual terminal, just place your LCD there. So here we have 44. Yes, this LCD there. Okay. So connect their corresponding pins. Pin number 14 with pin number 2. Pin number 13 with pin number 3. 12 with 4. And 11 with 5. Okay. And similarly connect pin number 6 with 6. 4 with 7, and put ground. Let's put ground there. This is the connection diagram of your typical real-time clock module. So now it's time to write the program. Could anybody tell me why should I write this 32.768 kilohertz here for this crystal oscillator? Can anybody tell me what the reason of selecting this such kind of frequency? Anyone? Why we have choose this 32.768 kilohertz for this crystal oscillator in real-time clock module? Anyone? Okay, because 2 raised to power 15 is 32768, if you know. And to generate 1 kilohertz frequency, it means we need 15 flip-flops. We need to make a counter with 15 flip-flops for generating 1 kilohertz frequency. And 1 kilohertz frequency is quietly similar to your 1 second count. Okay, so in short, I can say for generating a 1 second pulse, you need a 15-bit counter, or you can say 15 flips flop for that. And 2 raised to power 15 is 32768. That is 32768 hertz. So if you convert this 32768 into kilohertz, but obviously value will be 32.768. Right? That's why we are selecting 32.768 kilohertz for this crystal oscillator. Right? Just now write the program. Because it's a kind of I2C communication, include your library wire.h. For LCD interface, let's create an object of LCD and just enable the pin 7, 6, 5, 4, 3, and 2 because we have made the connection at this corresponding pin. RTC underscore DS1307, make a object of that. In the setup function, start serial communication at 9600 baud rate. Wire dot. Okay. Using this function, we are initiating the I2C communication. Start RTC module. LCD. Initialize the LCD. 24 plus 4. Just a moment. Okay, so just initialize LCD with 20 cross 4, that is 20 columns and 4 rows. In mode, 13 pin. There is no need 13 pin because we are not using any LED there. So if not RTC dot is running, serial dot println RTC RTC dot Just date time dot date time date time. Okay, so I'm initializing first time I'm initializing with the latest date time. So in the loop function, I'm capturing the current date time if this now dot hours less greater than 11 LCD cursor 14 column and 1 row print PM, right? Just write AM. LCD dot set cursor 0, right LCD dot print date LCD dot print. After this print now dot hours, sorry, date print date in decimal format. Then just print slash date then month then year, right? Then just put as blank space here. LCD dot set cursor 0 column and first row. So if now dot hours are less than 10, just I'm padding this with 0. LCD dot print now dot hour greater than 12, then I will print now dot hour minus 12 print now the hours. Then LCD dot print after printing hours, similarly print minutes. Minutes are less than 10 and 0. Similarly, if seconds are less than 10, then pad 0 with second. All right. No. Again, set cursor at the 0th column of 3rd row. Get day of week equal to now dot. No need to print, make this program so lengthy. Just that's all. Till now, just make a delay. Otherwise, you can also print the what the day is today. The name of the day. You can also just compile this program. Okay. Wire.h. One bracket is missing. Date time is not a member. Hours. Okay. Hour. Here you will find there is the text file of this program. Okay. Just close the yellow file. It's also visible. Just specify this yellow file with that and start the simulation. So in this way, you will get the real date time with the help of this date time function, the RTC module. So this is the program which could be understand side by side with this OTS. So here pin number 765432 all these pins are enabled. I have started serial module, serial communication, because at the serial port these are serial communication, these are. So wire.begin, I have started I2C communication because at the I2C port, 4th and 5th, these two at these two pin RTC is connected. That's why I have started. Wire.begin, RTC I have started. LCD I have initialized the LCD with 20, 4 means 20s are the columns and 4 are the rows. If RTC is running, then it will print a message. If RTC is not running, it will print RTC is not running, and it will adjust the date or time of the RTC with the corresponding data statement. Okay, in the loop, if the hours are greater than 11, then it will print PM there, and otherwise it will print AM. Similarly, at cursor 0, 0 at that position, it will print day, then it will print day / month / year. Similarly, at cursor 0, 1 means 0th column and 1st row. It will print if hours are less than 10, then it will have a pad 0. It will print time, and if hours are greater than 12, it will subtract the value of current hours with 12. For example, in this case, 13 minus 12, it will print 1. Okay. This code here. Okay. Similarly, in the case of minute, it will print similarly minutes, then the seconds. Okay. So this is the program of a typical RTC, right? So if anybody have any doubt, or should I proceed to the next Bluetooth module? Okay. In the next program, we are going to connect a Bluetooth module with our Proteus software and control a typical a motor, or you can say an LED, whatever external entity you are able to connect with the Bluetooth mobile phone. Okay, so such kind of session experiment and some experiment. So make a new design, select the components, select the Bluetooth module there, HS0 SC05, select Arduino, and just place Arduino board there. Put your Bluetooth module. Just let me rotate this. Connect transmitting pin of this Bluetooth module with the receiving pin, and transmission of Arduino with the receiving pin of this Bluetooth module, right? And at the 13th pin, just have a LED. Connecting LED with this 13th pin. Okay, so in the next step, just select your Bluetooth device, go to Open Settings, and at the COM port, just check what COM port your Bluetooth hardware is connected. So here you will see at COM port 3, your Bluetooth is connected, right? So similarly, we are going to double click on that, and at the physical port, we are selecting COM port. So in that manner, this virtual Bluetooth device is directly connected with this Bluetooth of my hardware. So this is the first part we have completed. We have completed the hardware part. Now, write the software part for that, or you can say bootstrap program for that. So just open your Arduino IDE, make a variable text, pin mode 13, output, start the serial communication 9600, perfect. Okay. So till while this serial dot available a delay of 10 seconds, sorry, 10 milliseconds, and read a character from this Bluetooth device. And append this to a variable text. Text variable have a length greater than 0. It means we have received something. Whatever we are receiving, we are going to print for debugging purpose. If the value of text is typically say on, then what we need to do? We need to make the LED on. Similarly, if we have a message or instruction, make this LED off, we are logging the voltage, right? Then just blank this text to variable. Okay, save the program. Copy the hex file of this Bluetooth program. Okay, just test the circuit. Okay, no error is there. Simulation is working. So the next step, we need to design an Android app. There are two options. If you know the Android coding or Android programming, you can do at your end. If you are not familiar with the Android, then I'm showing you the second alternative of that. Okay. So just open your web browser and in the Google type MIT App Inventor. Click on the first link, MIT App Inventor, and then just make the page load. Okay. Click on Create App. Just sign in with your account. So I have already created two projects. Instead of going with that, I'm going to create a new project for your demonstration. Just create a new project, go into the project, start a new project, give the name. So here you will see the screen part, the demo screen is showing on your system. On the right hand side, just type the name, whatever you want. Make the alignment center. So next, what we need to add some components. So on the left hand side, we have a component window or user interface window. So in that, you will find a label. Just click on that and drag and drop this label to here. Okay. Just type the text of that, because the alignment is not for discrimination, orientation, portrait, sizing responsive. Height select, fill parent. Label, select the height automatic, width, fill parent. Okay. Type text alignment, mark it center. Just write your text there. Control LED. Next step, just place a list picker there. Make the width of this list picker again. Okay. Device. color default color background color blue. Then on the layout below, select horizontal arrangement, drop this to there. Okay. Just select width to fill parent. Again, user interface, add 2 buttons there. Button 1, button 2. Center, center. So we have a 2 button. Mark text this button for off LED. Text. Right. So the background color if we need. Next, print your connection status. I have a label for that. Right. So in this manner, we have created a simple GUI. So for connection, making a connection with Bluetooth, just drag Bluetooth client there. We have a Bluetooth client 1. Okay. So this is the GUI part we have completed. Now we have to write the coding part. Right. So just click on the blocks there. You will see some canvas part there. So here you just need to make a drag and drop kind of things to make your coding. Okay. So just click on list picker. You will see a lot of options are there. So just select when a list picker, we will select from the list picker. Before that, what we need to do, we need to set the list picker elements to Bluetooth client address names. Where is Bluetooth client address names? This. So before the list is showing in front of you, what we need to show all the Bluetooth clients connected with us in the list one. Then after that, if we select any particular connection, that is after clicking, what we need to do, we need to have some kind of if else condition, control logic. If then if call Bluetooth client.connect with address, to which address from the list one we have picked. List one dot selection. Okay. Then next, the other part you need to set level dot set text. label 2 dot subtext. Two dot subtext. Text 2. Subtext. Where is the subtext? This one. Subtext 2. Label 2 text. Just write a text there. Bluetooth disconnect. Right. Then when button 1 is clicked, we have to just check if Bluetooth is connected. Bluetooth client is connected. Where it is? Yes, Bluetooth client is connected. If yes, then call Bluetooth client or send text. Send text. Yes. Send text. What text? On. Similarly, when button 2 is clicked, if Bluetooth, if Bluetooth client is again connected, then send all to send text. Off. So this is the you can say coding part that we are going to implement. So just have a closer look to that. When a person click on the list picker one, before clicking on list picker one, we need to just fill this list picker with the all the Bluetooth devices near this, and just fill the addresses of these Bluetooth device into this list picker one. So after as and when you just click on a particular the address of any Bluetooth device from the list picker, if the this Bluetooth client is there, it just pass the address of this Bluetooth device to this Bluetooth client and show a message Bluetooth is connected to the label 2 that we have created in the previous step. You see the label design block, there is a label 2. This. Okay, so if you select any particular Bluetooth device, once it's get connected, it will show the connection status. Bluetooth is connected message there. So if you click on the button 1, if Bluetooth client is connected still, it will send a message from Bluetooth to the particular client. The message will be on, send the text on. And if you click on the button 2, the text will be sent off. Okay. So just go to the, after doing this task, go to the publish to gallery, click on that. Okay. Just remove this step, forget this step. Just click on this app, save APK to my computer. It will build the APK and download the APK file. Using this step, you are going to generate an Android APK. So the IET.apk file, this is going to download. So now I'm connecting my mobile phone with this computer and uploading this APK file to my system. So I'm going to install this APK file to my mobile phone. And put this computer into discoverable mode. So let me first pair the device. Okay. Unable to connect the devices. Device turn on. I'm going to on my alternate camera so that I can show you how this app will look like. Just a moment. Let me connect with my another number. तो जूम के अंदर सेकेंडरी कैमरा कैसे ऑन करते हैं पीछे वाला? सेकेंडरी कैमरा कैसे ऑन होता है पीछे? नहीं, पीछे वाला करना, आगे वाला नहीं करना। कहाँ से आएगा? इसमें? Okay. So now I think my screen is visible. So this is the typical app we have designed on this MIT Inventor platform. So just you on your Bluetooth connection, just pair with your existing device. I think pairing has been done. Just start your this. Just click on this choose device button. Here you will see the Bluetooth client available with pairing of your mobile phone. Just connect this first one, as my name of my system is Dexter. Exactly. The device is turned on. Device enable नहीं हो रही है। I think I have some issue with my Bluetooth device. I think that's why it's not working at your system. It probably will work. System is showing some Bluetooth adapter is in use. It cannot be turned off. Just a minute. We'll turn it off. One second. Okay, I will show you the output of that screen in the tomorrow session, because I think I need to start this computer, and having a restart, the meeting will automatically get off. I think that's the issue. Not able to connect. Not able to connect. Okay, I have an issue with, I think, my laptop, so I will show this output of this particular process in the next session. So if you have any doubt regarding that, you can ask me. I'm available here. The output of this simulation I will show in the tomorrow's lecture. So anybody have any doubt? I'm openly available here. If no doubt, then I think I should leave the class. No one? Okay, thank you. Thanks once again to be here. I think I should leave for now, and we will meet again tomorrow at 9 a.m. I think tomorrow is the last day, last session. So I think there will be only 2 or 3 sessions. I think tomorrow is only 2 sessions are there. So at sharp we will meet at 9 o'clock, and the Professor Ravi Prakash Pandey will have a some practical version of this red knot configuration, which is not but it's a configuration for Raspberry Pi gateway. So he will let you know some more about how red knot could be configured at the Raspberry Pi, and how this gateway just flush all the data it gets from the sensor to the corresponding cloud. Okay, and after the session of Dr. Ravi Prakash Pandey, I will again take the session, and will let you know about how the data can be used for machine learning approaches to have some prediction on particular event. We will have more on that. Thank you. Thanks once again.